Hi, my name is Emily Aiken. I'm a PhD student at UC Berkeley. And on behalf of myself and my colleague Nitin Kohli at the Center for Effective Global Action, or CIGA at UC Berkeley, I'm here to talk about our work on provably private data for targeting humanitarian aid. And while this talk will focus on the application of targeting humanitarian aid programs, to the extent that these programs are increasingly delivered via mobile money, this actually is going to be broadly relevant to various financial inclusion applications. So I hope it will be useful for all attendees of this event. So our work takes place in Togo, which is a small country in West Africa. During the COVID pandemic, the government of Togo launched an entirely digital cash transfer program called Novisi. This program was pretty special because people who applied for the program, rather than going in person to apply, they dialed a short code on their mobile phone and filled out a short registration survey via SMS. And people who were eligible for benefits received their benefits via mobile money. So the entire program was delivered over the phone entirely remotely, necessitated by the movement restrictions of the pandemic. Eligible beneficiaries received around $13 to $15 per month for 5 months. And Novisi as a program, as a digital program, really was very successful. It received on the order of 1.5 million registrations and ended up helping around 800,000 beneficiaries. But the big challenge for Novisi was to figure out how to target people who should receive cash transfers. The government of Togo didn't have sufficient budget to provide transfers to everybody in the country, so they had to somehow try to identify the poorest people to receive the transfers. But in Togo, like in many other low and middle income countries, there wasn't any kind of up-to-date registry of poverty to use to identify individuals who were very poor. And that's where our research group came in. So we worked with the government of Togo to develop a method based on mobile phone metadata to identify people who were living in poverty to receive Novisi cash transfers. So our method relies on the metadata that's recorded when people use their mobile phones. This isn't, for example, the information on like the content of text messages, but rather the data that mobile network operators record in their day-to-day activities about what transactions subscribers are placing. So it's information about like subscriber A calls subscriber B at such and such a time, and it goes through this cell tower, which gives you some broad notion of location. So this information does encode quite a lot of information about poverty. So phone use is really quite predictive of poverty. You can think about, for example, the number of calls that subscribers make. Wealthy individuals tend to place more calls than poorer individuals. Likewise, they might have more contacts, definitely more international contacts. They're likely to use more mobile data rather than just placing calls and SMS messages, which would be associated with a feature phone. They're also likely to be more mobile as observed through the different cell towers that they're using. And so all of this information is really quite predictive of poverty. It's just a matter of, well, first accessing the mobile phone metadata, which is held by mobile network operators, and then secondly, turning all of this information that's recorded into like a single prediction of poverty. So from the data access side, our research team signed data sharing agreements with the 2 mobile network operators in Togo who collectively cover 6 million subscribers. And we got access to all of the mobile phone metadata for those subscribers for about 6 months. We then calculated on the order of 1,000 statistics, or what we call features, describing how each subscriber uses their mobile phone. And then we conducted a representative survey over the phone with 10,000 individuals in Togo. So we conducted like a short poverty scorecard survey for these individuals to get a label of true poverty status, and trained a machine learning algorithm to predict underlying poverty from mobile phone data on this training set, and then use that trained algorithm to predict the poverty of all 6 million mobile network subscribers in Togo. So we did this exercise in Togo for the purpose of this Novisi program, but in research it's also been done before in Afghanistan as well as in Rwanda. And we see that across these various contexts, the machine learning algorithm based on phone data is typically explaining between a quarter and half of the variation in ground truth poverty as recorded in a survey. Now, we're going to talk in a lot of detail about the privacy concerns of using mobile phone metadata in this way in just a second, Before we get there, I want to talk about the accuracy of this approach to targeting cash transfers. So, from a research perspective, we were very interested in how accurate this approach was at really reaching the poorest people in Togo. And we wanted to compare how accurate the phone based approach, which I'm showing in this graph in green, was compared to alternative approaches the government of Togo could have taken. So we compared approaches that were feasible at the time in Togo. And really, because the government didn't have any up to date registry of poverty, the only feasible approach besides the phone based approach was geographic targeting. So just paying everybody living in the very poorest areas of the country. So the geographic targeting approach is either targeting the poorest prefectures or the poorest cantons, are shown in red on this graph. But then we also compared to some approaches that were not feasible at the time because they would have required going household to household and collecting survey-based data on poverty, like in a short poverty scorecard for every single household in the country. I'm showing those approaches in blue, and we look at two different poverty scorecard variants there, one called an asset index and the other a proxy means test, or PMT. In terms of how we actually evaluate accuracy, we're generally going to look at precision and recall, which is shown in the left bars on this bar chart. Precision and recall are very closely related to errors of inclusion and errors of exclusion. In fact, they're exactly the opposite of errors of inclusion and errors of exclusion. And then we also look at something called an area under the curve score. Now, what you really need to know about these accuracy metrics is that for all of them, higher is better. And so the main finding we had was that the phone-based targeting approach was more accurate than the geographic targeting approaches that the government of Togo could have taken during the pandemic, but not as accurate as going household to household and collecting really good data on poverty. So this research result, along with a number of other evaluations of the program, we published in a research paper in Nature back in 2022. And since then, we've been working with other governments and NGOs to scale this phone-based targeting approach to other countries and other contexts. But certainly a major concern as we continue to work on this approach is the privacy implications of using mobile phone data to target humanitarian aid. So I'm now going to turn it over to my colleague Nitin to talk a little bit about the kinds of work we're doing to try to use provably private mobile phone metadata in these targeting algorithms.
Thanks, Emily. Hey, everyone. My name's Nitin. I'm a postdoc here at SIGA, and I focus a lot on privacy. So let's go down a little philosophical interlude and chat about privacy, and in particular, privacy arising from mobile phones. Many of us know just from everyday experience that we take our phones with us almost everywhere. When we wake up in the morning and head to work, when we go to the gym, when we go to the supermarket, when we go to buy our favorite novel at a bookstore. And while we take our phones to a lot of places, the locations we visit with our phones actually then can paint a detailed picture about certain habits and behaviors and beliefs and associations we have in our lives. For this reason, many folks have been considered about the privacy concerns that arise from tracking mobile phones. Because as we know, locations have meaning and the social meaning leaks information about us. This is actually has implications beyond just like what the locations mean about us. In particular, knowing a few number of data points about an individual can allow you to re-identify them even when data is anonymized. So, for example, let's suppose we know just 2 data points about about some individual. It turns out, as De Montoya et al. Showed in 2013, that you can re-identify around 50% of individuals using just those 2 data points. So, kind of for intuition here, imagine how many people went from where you live to the place where you work. And if unless you and your roommate work together, the answer is most likely 1, right? And as we actually increase the number of data points from 2 to 4, we're able to re-identify roughly 95% of individuals. So for this reason, mobile phone data has particular privacy concerns arising from it. It's not only that the locations and the information about where we were that can leak information about us, it's also the fact that multiple points together can extract out who we are, even in the absence of an identifier. So this kind of makes this kind of creates a tension a little bit, because as my colleague Emily pointed out, we know that mobile phone metadata can be used to target humanitarian aid, and we know it can do better than the geographic targeting in the case of Togo. So what we'd like to do is kind of find a way to enable the type of targeting that we could do in Togo, but using the mobile phone metadata in a way that's provably private. And we're going to tease out what that means in quite a bit of detail here. So In order to kind of set the stage for where we're going to go, let's imagine the three actors we have involved in our problem solving process, who we'll kind of label as the mobile phone operator who has the data, researchers who get the data and build models and do predictions, and then the government who receives essentially a Boolean vector on whether an individual is experiencing poverty or not. And what we want to kind of do is we're going to engineer this workflow to have nice privacy properties. So, what do we mean by that? Well, let's set up some walls of separation here first, and let's try to kind of scaffold where we're going to go. So, the mobile phone operator has this mobile phone metadata. And as my colleague Emily stated, researchers, us, got featureized versions of this metadata to create models with. However, what we want to do is instead of just getting features, we want to create privatized features. And I'm putting this in quotes here because we'll make it clearer on the next slide. And once we have this privatized featureized data set, we're going to build machine learning models and make predictions on individuals to then essentially give the government another Boolean vector of zeros and ones to determine whether an individual is above or below the poverty line. And for this to have any meaningful privacy guarantee, we want to make sure this flow of information is just unidirectional. That is, we want to do some maths to prove that you can't go backwards in any case. So in particular, this means that the government and the researchers will not be able to learn about the mobile phone metadata that the mobile phone operator actually has. One might hope that we could just use existing privacy enhancing technologies out of the box and address the issues we presented on the previous slide. However, that turns out to not quite be the case. So in this diagram here, we have three approaches to targeting. The first is the approach my colleague Emily mentioned, where we just do the NoVC data using featureized data, no extra privacy inserted. In this case, the accuracy of the models we're able to build is 69%. So this means that the model is able to correctly classify individuals as above the poverty line or below the poverty line 69% of the time. If we compare this to the two most common privacy enhancing technologies that are used in practice, differential privacy and k-anonymity, we see that there's actually a drop in the accuracy metric from 69% to 63% in the case of differential privacy, and even sharper to 59% in the case of k-anonymity. And while these numbers might just look like a 6 or 10% drop, if we actually contextualize what these mean, in the context of NoVC and the entire scaled up to the entire continent of Togo, or to the entire country of Togo, this means that 398,000 fewer individuals would receive humanitarian aid who were actually below the poverty line, which actually puts us in context to how these losses in accuracy translate to individuals. Even more so, if we take a look at the dash line here for geographic targeting of the poorest prefectures, had we just ignored using mobile phone metadata altogether, the accuracy would have been 66%, which would have beaten both of the privacy enhancing technologies that already exist today. So this suggests that if we want to actually use privacy enhancing technologies to target humanitarian aid better, we have to go back to the drawing board a little bit and do something clever. So let's go ahead and do that. And in order to do that, we kind of have to conceptually realize why things went wrong a little bit. And let's focus on the case of differential privacy in particular for this talk. So differential privacy is a mathematical promise that basically guarantees that too much won't be learned about any individual from the analysis of information. So in order to meet this promise, methods like differential privacy have to strategically sprinkle noise very cleverly in certain ways to hide the presence or absence of any individual. And by adding in this noise, we see there's kind of a trade-off here. The more noise we add, the more we've protected the information of an individual, but at the same time, we've then made their information less useful for targeting. And conversely, the less noise we add, the less privacy we're giving them, but they're getting more accurate information for targeting. So differential privacy was really created for statistical tasks where you want to do things like compute a population mean or a population median and things of this nature. However, the real issue comes because we can't learn too much about any individual, because that's kind of the point of targeting, right? We're trying to figure out which individuals are actually above the poverty line or below it. So for this region, so for this reason, differential privacy is kind of mismatched for what we're trying to do. But that doesn't mean we have to toss differential privacy out the window completely. This means we can refine it in a way to enable us to learn a bit more about individuals while still keeping a lot of the nice privacy guarantees it has. And I'm going to leave all the details for a forthcoming publication. Read it. And what we find is when we actually use our refinement of differential privacy, we're able to do much, much better than both classic differential privacy and k-anonymity. So, in particular, uh, the traditional Novici approach had a 69% accuracy, and using our approach, we only actually decreased that to 68%. When we translate this accuracy loss into humans, only 3.4 only 3,400 fewer individuals experiencing poverty would now not receive humanitarian aid. So that's quite a big increase in what we saw before. Uh, we're able to add an additional roughly 190,000 folks to be covered with privacy enhancing technologies compared to differential privacy and k-anonymity. So a drastic improvement in the accuracy. However, this drastic improvement in the accuracy might pose a question. Is this really a meaningful privacy guarantee, right? All we're doing here is just comparing accuracy numbers. And what we find is that, yes, actually, this is a meaningful approach. So, what we're going to do is look at two different types of privacy metrics here. The first metric is called singling out protection. So, what is singling out? Singling out essentially is the task of looking at a data set that's been quote unquote privatized and generating a predicate that can uniquely pluck out one individual from the unprivatized data. That is, looking at something that we've deemed as safe, can we still learn about an individual in the original data set? And what we find is in the traditional approach, where Novici was used, uh, only 1% of the data was immune to singling out attacks. That means we could re-identify 99% of the individuals in the original data set uniquely. Differential privacy is really baller at this. It has a provable guarantee that saying singling out is stopped, like full stop. In our approach, we see that actually, because we've had to refine differential privacy a bit, the singling out protection drops from 100% to 86%. So, what this means actually in context is the following. From the perspective of singling out protection, compared to the traditional approach where no privacy was, we're 8,500% more private. But compared to differential privacy, we're 14% less private. But we know we did this entire exercise because we cared about humanitarian aid. So when we weigh the 14% less private with regards to the roughly 190,000 more individuals who get aid, we see that this actually paints a very different picture here. The method we have has low privacy risk relative to the humanitarian benefits that we found. An alternative metric we could have used to measure privacy risk is something called an attribute inference attack. So an attribute inference attack is as follows. Suppose an individual has some subset of the real featureized phone data. And what they want to do is by looking at the privatized version, can they infer the real columns that they don't have? So that is, can we still infer information about individuals in the unperturbed data using the perturbed data? And what we find here is actually the traditional approach, once again, not much privacy protection, as expected, no noise was added. But our approach is much closer to that of differential privacy here. And in particular, by using our refinement of differential privacy over classic differential privacy, the privacy risk is only 5% lower. And we still enable roughly around 190,000 more individuals to receive aid correctly. So for this reason, we see that not only is our method more accurate, but the level of privacy that we're giving individuals is still meaningful. And in fact, much more meaningful than the traditional approach over there in the bottom left corner of just 1%. So we made astronomical improvements relative to that. So what's the moral of the story here, right? As my colleague Emily mentioned, machine learning and mobile phone metadata can be used to target individuals that are living in extreme poverty. And what I've discussed here is that if we try to use existing privacy enhancing technologies to mitigate some of the real privacy concerns from using mobile phone data, there would be a sharp cost in terms of the ability to accurately administer humanitarian aid. So, our refinement of differential privacy noticeably improves this trade off. The privacy increases are actually quite a lot compared to the Novisi program, and at the only marginal cost of a few thousand folks who wouldn't actually receive aid then. And the important thing is, while we talked about this in the context of humanitarian assistance, these methods can be leveraged by financial institutions for many of their machine learning and AI applications as well to bring people into the financial ecosystem. So I want to close it off by just kind of noting that when we use privacy enhancing technologies appropriately in conjunction with meaningful policies and meaningful practices, we can actually enable innovative uses of data that provide real, robust, and meaningful protections for individuals without having to sacrifice innovation. And we're hoping that this research can actually catalyze more responsible and consumer oriented approaches to innovation in the financial services. We'd love to stay in touch. Thank you.